Section 1.4. Here are our objectives. Number 1, add and subtract complex numbers. 2, multiply complex numbers. 3, divide complex numbers. 4, perform operations with square roots of negative numbers. Ready? So what is a complex number, first of all? Remember what it looks like? That's a complex number. The first part is what makes it a complex number? Different parts, right? The first part is the real part. The second part, do you remember? Second part is the imaginary part. How do you tell the difference? Yeah, the imaginary part has the I, right? Okay. Some things just to remember real quick before we get to the actual objectives. Just so we remember, what is the square root of -1? I. Okay, that's where the I comes from if we take the square root of -1. Okay, if I squared both sides, I would get I squared on this side, right? What would I have here? -1. So another thing that you need to remember is that I squared is -1. Okay, that'll make things a lot easier especially when we get to multiplication. Okay, there's a definition that I need you to know. A plus BI equals C plus BI, except that's supposed to be a D. Sorry about that. If and only if. Have you guys ever seen this before? The IFF. It's like a abbreviated if and only if. You can write IFF and you know it means if and only if. Okay? So A plus BI equals C plus DI if and only if what's true? What has to be true for this to... What does A have to equal? C. And what does B has to equal D? Okay? See, what's cool about this is if and only if means I can read it two ways. I can say A plus BI equals C plus DI if A equals C and B equals D. Because it's if and only if, I can also say A equals C and B equals D if A plus BI equals C plus DI. I can read it both directions if that really says if and only if. Okay? So both ways works here. All right? So now let's get to our actual objectives. Those are just some things I need you to remember. Okay? Add and subtract complex numbers. So if I give you a problem like 2 plus 3i plus 4 plus 5i, how do I solve that problem? What's the typical verbiage that we use? Combine like terms, right? What am I really meaning? I'm really meaning combine the real parts and combine the imaginary parts, right? So what is 2 plus 4? And what is 3i plus 5i? 8i. Done. What if I had 2 plus 3i minus 4 plus 5i? I'm still combining like terms, but I am subtracting, right? And I have to remember to subtract each time. Typically, you don't forget the real parts. Typically, you don't forget 2 minus 4, which is -2, right? Typically, what you'll forget is the imaginary part. 3i and 5i, oh, that's 8i. Except I'm saying 3i minus 5i, which is -2i. Okay? So a lot of times what people choose to do is they choose to think that there's really a -1 right there instead of just subtraction. And they distribute that -1 to each of those terms. So what they're doing is changing the signs inside the parentheses for each of those terms so that they remember that we're subtracting. Okay? You can do that, or if you're just comfortable straight up subtracting, do it. Okay? Any questions on adding or subtracting? Comfortable? Awesome. Multiplication. Start off easy. Do I do this any different than if this was an x? No difference at all, right? Can I combine? Wait, how come from right here I don't say 14i?
Because the 6 is a real part.
Can you ever combine real and imaginary? Space Jam. That's it. Maybe Who Framed Roger Rabbit. That's the only time combining real and imaginary works, right? Otherwise, you just can't do it. Okay. But what about multiplication? Can you combine real and imaginary? Yes. Okay, so when I distribute, I can distribute the real to the real, and I can distribute the real to the imaginary. Except, how about if I write 6? I was trying to do the last part first. Sorry. Please forgive me. What if it's like this? 3 plus 4i times 5 plus 6i. What do? Distribute again. 3 times 5? 15. 3 times 6i? 18i. 4i times 5? 20i. And then 4i times 6i? 24i squared, but I know that I squared is -1, isn't it? So this is -1, so I have -1 times 24, which is really -24, right? So I have a positive 15 and a -24, so -9. And then I have 18i and 20i. 38i. Okay? Any questions so far? Adding and subtracting we've done. Whoa. Adding and subtracting we've done. Multiplying we've done. Ready for dividing? Okay. So typically the division problem is not going to look like a typical division problem. It's going to look more like a fraction. Okay? It's going to look like 3i over 4 plus I. And it's going to say simplify. Well, the thing is that we don't want i's in the denominator at all. Okay? So do you remember talking about complex conjugates in Algebra 2? So I'm going to go back up here to some of these and use these as these. This is the answer. I want to find the complex conjugate of this. I'm going to write it over here in orange. You okay with that? Okay, so if I have 6 plus 8i, you need to understand that the complex conjugate is 6 minus 8i. How did I get that? I kept the real part exactly the same. Opposite imaginary part. So what's the complex conjugate of this one right here? -2 plus 2i. I keep the real part exactly the same, and I have an opposite sign for the imaginary part. You okay with that? So when I have a division problem, I need to find the complex conjugate of the denominator. Okay? The only thing I can multiply this fraction by that doesn't change its value is 1. But I get to choose the value of 1 that I use, right? So find the complex conjugate of the denominator. 4 minus I. If I multiply the denominator by 4 minus I, what do I need to multiply the numerator by? 4 minus I, because that makes a fraction of 1, and that's what I need. Does that make sense? So in the numerator, I distribute here and here, and I get minus 3i squared, right? So if I simplify 12i minus 3i squared, well, this is -1, right? So -1 times -3 is 3. And I want to go ahead and write 3 plus 12i. Why do I want to write 3 plus 12i? Real number, complex number, right? Okay. And then that's my numerator. What happened to my denominator? Distribute 16. Distribute minus 4i. Distribute plus 4i. Can you see why I chose the complex conjugate now? Because what's going to happen to the I terms? Good. I times negative I. Negative I squared. But I squared is -1, so I really have +1, right? So I have 16 plus 1 is 17. Because like we noticed a second ago, this goes to 0. Okay? And look, is this simplified? Is there an I in the denominator? No, then that's the correct answer. Okay? Now, here's what I don't know. Okay? I don't know if the computer wants this as an answer, or what's this equivalent to? 3/17 plus 12I 17. That's what I don't know. I don't know if it wants this or if it wants this. Does that make sense? All right, just as a reminder real quick, let me show you something. As soon as my calculator comes on. Are you going to come on today? Oh, it's because I'm trying to show you something, so it has to do this. I love it when it does that. While we're waiting for that to come on, we do have one more thing to talk about, performing operations with square roots of negative numbers, but that's only going to take a couple examples before you guys are going to understand what to do, okay? Come on, you can do it. You can do it. Almost there. Almost. Almost. Maybe. Are you tired? Me too. It's okay. Yes. Okay. So just real quick, I want to do 2 plus 3i. And then the I we're using is not the I that's the letter. It's the I under the pi key. So if I press the pi key, then this comes up and I have to choose I. And that's actually in parentheses. Plus 4 plus 5i. Oh look, 6 plus 8i. Okay. Now, while these are pretty easy and you can do it in your head, that's a great way to check, right? But if we're doing something more like 3 plus 4i, 5 plus 6i. Now you know I want you to be able to do this without a calculator, right? So I show you this way first, but look, it's the same. Okay? And even better, 3i over 4 plus I. Bam. Okay, just as a reminder, it's there to help you check. Okay, let's do some operations with square roots of negative numbers. Okay, and here's what I mean by that. If I say the square root of negative 18 minus the square root of 8, negative 8, sorry, is that something I can simplify? Well, remember that what's happening here is actually the square root of negative 1 times 9 times 2. Why would I choose 9 and 2 instead of like 6 and 3? You know the square root of 9, right? So I purposely choose something I know the square root of. What's the square root of negative 1? I. What's the square root of 9? 3. What's the square root of 2? I don't know either. Okay? Well, what about, then I have minus. What about the square root of negative 8? What's that the same as? So negative 1, 4, and 2. What's the square root of negative 1? I. What's the square root of 4? 2. What's the square root of 2? I don't know either. Okay? So now that I have similar square roots, can I actually do the subtraction? What's 3i minus 2i? 1i. And right now we're kind of treating that square root of 2 as a variable, right? It doesn't change. It doesn't have a value. I mean, it has a value that doesn't change, but I just kind of drag it along. Does that make sense? Okay. What if I ask you to do a problem like negative 1 plus the square root of negative 5 squared? Could you do that? Well, what does it mean to square something? So multiply by itself. So negative 1 plus the square root of negative 5 times negative 1 plus the square root of negative 5. Okay? Please don't just square the first term and square the second term. You're going to get the wrong answer every time. Okay? Because see what happens here is I need to distribute, right? What's negative 1 times negative 1? Positive 1. What's negative 1 times the square root of negative 5? Square root of negative 5, right? What's the square root of negative 5 times negative 1? Thank you. It's negative square roots of negative 5, right? So what's the square root of negative 5 times the square root of negative 5? Right? If I'm squaring something that's in a square root, I just get the thing that was in the square root, right? Okay? So I have a 1 and a negative 5. I'm combining like terms now, so I have a 1 and a negative 5. What does that give me? Negative 4. And then I have a negative square root of negative 5 and a negative square root of negative 5. How many of them are there? 2. So minus 2 square roots of negative 5. But do I want to leave a negative 5 in a root? No. Where does it go? Well, you could think of it like this. Negative 1 times 5. Do I know the square root of negative 1? I, right? So I have negative 4 minus 2i. Do I know the square root of 5? No. So that's just the answer. That's all the way simplified. Okay? Anybody have any questions? Good?